Good morning, everyone, and welcome to the first installment of our Climate Toolkit Pittsburgh webinar series. I'm Richard Piacentini, President and CEO of Phipps Conservatory, and it's a pleasure to have you all join us today. If you're new to this group, Climate Toolkit Pittsburgh is a free resource and collaborative network launched by Phipps to connect local nonprofits around climate action in the greater Pittsburgh region. We're currently partnered with 33 organizations and look forward to growing this program with you. This is a new initiative modeled after Phipps' International Climate Toolkit Initiative for museums, gardens, and cultural institutions, with many possible avenues for action and coordination ahead of us. And now I'd like to turn it over to Andrew Lample, our Climate Toolkit Manager, to introduce today's presentation. Andrew.
Thanks so much, Richard. And thank you all for being here today. We are thrilled to kick off our webinar series and start growing our Toolkit Pittsburgh resource library with content and climate solutions with you all. So it's my pleasure to introduce Tobias Chan, the Director of Building Performance and Engagement at Green Building Alliance. In case you're unfamiliar with Green Building Alliance's work, GBA works across sectors and with communities to create beautiful, efficient, high-performing spaces that are healthy for people, the environment, and contribute to a thriving economy. Founded in 1993, GBA is one of the oldest green building organizations in the United States. GBA is also the founder and convener of the Pittsburgh 2030 District, an incredibly impactful network of over 540 local properties, which together have avoided 340 million metric tons of CO2 emissions. Tobias, thank you so much for being with us today and sharing GBA strategies for improving local building performance, efficiency, and indoor air quality.
Thanks, Andrew, and thanks for giving the introduction for me. I can, I guess, skip the first slide then. But yeah, I'm really happy to be here. Happy to talk a little bit about, some of the things that I'm really passionate about: energy efficiency, and indoor air quality. So this presentation, I'll give a brief overview of some no and low cost energy efficiency strategies that you can implement in your buildings, hopefully right away. And then I'll close with a little bit of information about indoor air quality, and again, some strategies for improving that as well. And as Andrew said, my name is Tobias Chan, Director of Building Performance and Engagement for Green Building Alliance. We've been around since 1993, as he said, doing a lot of work in the built environment. I will skip this slide and my intro, but I'll talk a little bit about, what some of the things that we do and we offer to our partners. A lot of what we do, or a lot of what I do, is our building utility use assessments or preliminary energy assessments. So looking at your building's utility bills, they really tell a story about how buildings use energy. And then through that and our coaching and guidance, we can help you identify opportunities for saving energy and water within your building. But we also want to help you get those projects underway. And so through that, we can help you locate funding opportunities, whether they're rebates, tax credits, loans, or grants. We also offer, some grant writing support, letters of support, things along that line. We also offer education and training sessions. So from opportunities like this, we can also bring in service providers, case studies, people who have done the work, who are more familiar with it and can, share some information about things that they've done, and give you inspiration. We also offer credentialing support. So for Lead Green Associate, we offer training. We also offer G Pro Operations and Maintenance, both of which are professional credentials. And then lastly, to continue to help get your projects underway, we have connections with service providers who can, give you support for your projects, help you get them started, help you with construction, renovations, retrofits, get your projects over the finish line. So without further ado, I will dive into our content here. And before I talk about some of our energy efficiency strategies, I wanted to give a brief overview of energy use within buildings, and what some of the systems and components are that we're looking at. And so, firstly, is the building envelope, which, while it doesn't use energy, it will impact how your building uses energy, specifically the HVAC system. And when we talk about the building envelope, we're talking about essentially the exterior of the building, which includes the walls, the roof, the slab or foundation, the windows, and then the doors. And then the actual components of the system that we're looking at are going to include your HVAC, so heating, ventilation, and air conditioning, your water heating system, the building's lights, and then the last category, which is plug loads and occupant behavior. So we'll talk about that later on, but that's really just accounts for any other uses within your building, pieces of equipment, appliances, things along that line. And I just thought it would be interesting to share a little bit about, some of the breakdown of how we expect buildings to use energy. So this is looking at small retail and offices in Western PA. This is from a data set called Comstock, which is it's no longer NREL, but it's the National Laboratory of the Rockies, I think. And it's a really interesting data set that tries to model a bunch of different buildings across the U.S. and see how they use energy. So this is just a sample breakdown, but one thing we can notice right off the bat is that heating, cooling, and ventilation represent about 70% of the energy used for this subset of properties. So again, really important, not only just to look at that system, but to also look at building envelopes. We recognize that a lot of our buildings are getting older, may not, have been built super efficiently, and certainly over time they lose performance. Failures start to happen in the building envelope. We see cracks, systems degrade. So definitely really important, to touch that as well. So I'll talk a little bit about the building envelope. When we think about the building envelope, it's really important, not just for energy efficiency, but also for IAQ as well. So hard to illustrate this graphically, but this is what we have. So the building on the left, has a lot of leaks, maybe around the windows, doors, maybe there's other cracks in the building envelope. Probably doesn't have good insulation, and as such, it's going to require more energy to heat and cool the space. On the flip side, maybe they've now done some renovations. They've replaced the windows, they've installed some new insulation, they've fixed some of the air leaks. The envelope's now tighter, so they're losing less conditioned air to the outside through those leaks that the older building has, and thus they now need less energy to properly condition the space. Additionally, they are also going to see some IAQ benefits because they've sealed up some of those cracks. The air that's coming into the building is now, or is generally coming through their mechanical ventilation system, or it should be. So it is getting filtered, removing some of those pollutants, helping people with asthma and allergies, be a little bit more comfortable within the building. Now, talking specifically about some strategies. So one thing that we would recommend is to install weather stripping around your doors. You can also install that around windows as well. There's different types, different varieties for different applications. They can all be installed relatively simply. But the impetus here is, around doors and windows, the perimeter, there might be, some loose spots where the seal isn't great. There might be gaps. And so not only are you allowing drafts in, but you're bringing, again, whatever is in that outside air, whether it's dust, whether it's pollen, could be noise as well. All that is now entering your building a little bit easier. So weather stripping, will help reduce those, drafts within your property around those areas. And another thing here, we see in a lot of, especially older buildings, they may have wall or window mounted AC units. So this image on the right shows that. We have a wall mounted unit underneath a window. Below that is a baseboard heater. And on the left-hand side, we have a thermal image, which is looking at essentially the temperature of these different pieces of equipment. So the cooler colors, the purples, blues, are going to be showing colder temperatures, and the warmer colors, the reds and yellows, are indicating warmer temperatures. So what we can see here are a couple of things. First off, the window and the air conditioner are really, really cold. So this indicates that A, the window is probably single pane. The seal is probably not very good. It's likely letting a lot of cold air into the space. But what we also see is that the air conditioner is also letting a lot of cold air into this space. So very, not great thing to have. Obviously, in the summer, it's very beneficial, but in the winter, we don't want our AC to be bringing in cold air intentionally or unintentionally. And really, what this amounts to is that the average room air conditioner, whether it's wall or window mounted, is equivalent to having a 6-inch hole in your wall. And I think if you or I saw a 6-inch hole in our wall, the very first thing we would do is plug it or cover it. And so you should do the exact same thing with these AC units. There are a lot of off-the-shelf solutions that are available for both interior and exterior applications and configurations that you can use to cover these AC units during the winter, during the heating season when they're not needed. And again, that'll help reduce those air leaks and drafts that are coming through these units. Now, if you have a window unit, we would of course recommend that you should actually just remove it during the winter and the heating season, but covering it again is also another solution here. There are a lot of other openings within your building envelope for things like pipes, things like electrical wires, ductwork if you have it. And there are different solutions that we would recommend for these areas as well, because anytime you have an opening in your building envelope, there's probably going to be cracks around it. There's going to be gaps where, again, you're letting that interior or exterior air into your building. So for pipes, you can use things like spray foam. For electrical boxes or outlets, there are gaskets you can get to mount on the inside, again, just to try and stop some of those leaks. And then for ductwork, there are special duct seams or duct tapes that you can use to not only seal around the opening for the ductwork in your building envelope, but also the ducts itself to keep the conditioned air within the duct, keep it from leaking out into spaces that you may not need it. And of course, when we think about windows, we naturally think about, how many panes of glass it has, how good the seal is, and those are definitely important. But replacing windows is a pretty costly initiative. So there are other things that you can do that will improve the performance of your windows. And a lot of those are going to be window coverings. So when I talk about window coverings, I mean things like shades, blinds, curtains. That could also include overhangs or awnings, and then window films. And these really bring a variety of different benefits besides just decoration or aesthetics, depending on the type of system that you go with. They can help with controlling daylight. They can help with improving the thermal comfort, so reducing the heat loss or heat gain through the window. Of course, they also help with privacy and glare control. So depending on the type of system you go with, you may get some of these benefits, you may get all of them, you may only get one, but it might be really good at that thing. So again, there are a lot of different options here for just traditional blinds. There are different styles that can really help with thermal comfort, and there are other things that you can do there as well. One other thing I'll also note here, not energy efficiency related, but especially in urban environments where there's a lot of glass, a lot of tall buildings, we do see often that birds run into that glass and they typically do not survive that collision. Your glass may or may not survive that collision as well, depending, I guess, on how big the bird is. So there are different options for bird-safe glass, which again just reduces the likelihood that they're going to run into your building. Again, not energy efficiency related, but definitely another thing to note here. And then additionally with windows, the different seasons, you want different things. So, and you're going to get different things because in the summer, the sun is generally higher in the sky, in the winter it's lower. And you can actually take advantage of this. So during the summer months, you want to make sure that your east and west windows are covered, especially during the morning and evening, because the sun is going to shine directly in, and we don't want that solar radiation, that heat gain. You can also use an overhang or awning to prevent the sun from getting into the south-facing windows. On the flip side, during the winter, the sun's lower in the sky, so any southern windows are going to get a lot of sun, and we do want that. We want that heat gain during the summer from during the winter from solar radiation, so you can take advantage of that as well. So just another thing to note with windows, that they can kind of be a double-edged sword depending on the season. And the last thing I'll talk about here is doorways. So of course, when you open an exterior door to your building, you are letting that unconditioned outside air in, and you are letting your conditioned air outside into the environment. And we don't want that mix, not only for energy efficiency's sake, also for thermal comfort, and again, also for indoor air quality. So there are a couple options here with doors that we can use to really combat that and prevent some of that mixture of indoor and outdoor air. This comes in the form usually of vestibules, so often these are built into the building. And the goal there is that only one set of doors is open at a time, so you have a pseudo airlock, preventing direct mixture of those airs and improving the efficiency of your building a little bit. You can also get temporary vestibules for the winter or summer. Here's an example here. Something similar, revolving door, so it is more space efficient and, in my opinion, a lot cooler to walk through. But that provides similar benefits as well. Now, if you don't have space for those, another option is an air curtain. So it is a unit mounted above the doorway, and it operates on a similar principle of preventing unconditioned air from entering the space whenever the door is opened. But it does this by projecting a barrier of fast-moving air across the doorway that helps create an air seal. So not only does this prevent the indoor and outdoor air from mixing, but it also helps limit flying bugs from entering your building and dust as well. So I've talked a little bit about the building envelope. Now I'm going to share a little bit about the HVAC system, or HVAC. And a lot of this is routine maintenance. HVAC systems can be pretty complicated. We would definitely recommend, a trained technician do a lot of the work, but there are a couple things you can do to improve the efficiency of those systems. And the first thing we're actually going to talk about is space heaters. If your HVAC system is working properly, if your building envelope is relatively quality, you shouldn't really have a need for personal space heaters because they are very, very inefficient. A traditional space heater, again, is going to add a lot of electric load to your building, and that's going to cost you a lot. And these prices are probably a year old when we initially did these calculations. And, given inflation and how much energy bills are going up, definitely add some to this. But in this estimate, and this, again, maybe a little bit of an overestimate, but if you were to run a 1,500-watt heater for about half the year, 40 hours a week, so the average work week, it could cost you upwards of $1,700 a year. And again, that's just for one unit. If you have multiple units throughout your building, that's going to cost you even more. So we would definitely recommend trying to minimize space heater use. There are more efficient options out there if you really need to use them. But as a whole, they are very inefficient to run. On the routine maintenance side, there are a lot of things that you can do just to keep an eye on your system to make sure it's operating efficiently. And one of those is going to be replacing air filters. If you have a furnace, a lot of homes, you'll have to replace the air filters. Commercial units, you may have to as well. The general rule of thumb is every 6 to 12 months. 6 months is kind of the standard. Manufacturers may have different specifications and recommendations. So, whatever they say is what we would recommend. But the reason behind this is that dirty filters, so the one on the right here, in this image, they make the unit work harder. It has to overcome more resistance to push that air through, so it has to use more energy. So cleaner filters, again, are going to be more efficient, and they'll also, do a little bit to improve occupant health and indoor air quality as well. A couple of other routine maintenance tasks. So, in a very similar vein, making sure that your outdoor units are clean. Also, duct work as well. Make sure there's no leaves or debris on and around those units. Because again, the dirtier the unit, the more it has to work to get that airflow into your space. Same thing with air vents. If you have a forced air system, so this top right image here, make sure that there's nothing in front of it, like a piece of furniture, or in this case, a potted plant, because again, the same principle, more resistance, more energy needed to push that air through your building. And the last thing I'll talk about with routine maintenance is just keeping an eye on your system. We recommend at least, doing walkthrough a couple times a year just to look at your system. So here's an example here. They have a ducted system, and you can actually see here that the ductwork is not even connected to the furnace. So all that hot air that the furnace is trying to get to the building, most of that is escaping before it gets to the distribution network. So a really important thing to notice. Hopefully you won't see anything this drastic, but maybe you'll notice leaks or damage, especially around connections and joints. You might also see, maybe you'll notice broken parts or worn out parts. If you're noticing inconsistent temperatures or maybe an unusual noise you haven't heard, frequent system cycling, these are all things that we would definitely recommend that you get checked out. And we also recommend preventative maintenance. We recognize these systems are very complex. They're running a lot of the time. So much like your car, your car goes in for oil changes, you get it inspected every year for the state, and they'll identify, some things that can be improved. Your HVAC system is very, very similar. We recommend twice a year, once in the fall, once in the spring. The fall, they'll typically inspect the heating system before the winter, and then in the spring, they will typically inspect the cooling system ahead of the summer. Next thing I'll talk about is temperature control. So, depending on the season, you should change the set points of your thermostats. So, in the winter, they should be a little bit lower. So, recommend no higher than 70 degrees. Whereas in summer, you should raise them a little bit, no lower than 74 degrees. So again, you still want to keep your building comfortable, but you do have a little bit of wiggle room. Because it's colder outside, you can lower the temperature a little bit. You don't need to keep it at 75 in the middle of winter. People will still be comfortable at 70. I keep my apartment at 66. It's a little cool, but again, like still comfortable, not freezing. And in the summer, likewise, you don't need to keep it at 70 degrees. People will still be comfortable at 74, at 75, and things like that. And then if it is nice outside and you are opening windows, make sure that you turn off your heating and cooling system when your windows are open to avoid wasting energy. Another thing you can do is to use setbacks or schedules. So when your building is unoccupied, which if you own an office or a retail space, there's likely going to be 10 or 12 or even more hours of the day where there's no one in your building. So you don't need to keep it conditioned to the same level as normal. So you can let that temperature kind of drift down or drift up depending on the season, about 5 to 15 degrees outside of your normal set point. So for example, this graph here, we see if we kept it at a constant 70 degrees, it would be 70 degrees 24 hours a day, 365 days a year. But if we recognize that, hey, from 7 p.m. to 6 a.m., there's no need for the building to be conditioned. There's no one in there. So we can let the system drift down. In this case, we've chosen 55 degrees. Again, it doesn't have to be a 15-degree difference. You can go a little bit less. But this is money. This is wear and tear on your system. This is energy that you're not using to condition that space. And again, you'd want to ramp it back up before people arrive in the morning. But this is an additional way to save money that again, really doesn't cost a whole lot. One way that you can do this is through programmable thermostats. So most thermostats, like the one in my apartment, you set the temperature and that's it. It's that temperature until you change it manually. Programmable thermostats are going to allow you to set different schedules and set different temperatures for different times of the day and different days of the week. They vary a lot in features. Some of them you can do one schedule for every day of the week. Some of them are just weekends and weekdays. So you have two different schedules. But again, they're going to allow you to do some of these, rollbacks of temperatures during unoccupied times. Definitely important to note that not all of them will work with every HVAC system. So depending if you have a single or multi-stage HVAC system, thermostats may only work with one of those. So definitely something to keep an eye on if you're going to purchase these or get them installed. And if you have a more complicated system or a larger building, we would recommend installing a building automation system instead of going with programmable thermostats. You could definitely do both. But a building automation system is going to give you much more detailed control of different spaces. It can also control beyond HVAC, so you could also control lighting, you control security, a bunch of other things as well. So again, much better for larger buildings than it is for a small office building, for example. So I'll move on to section number 3, which is going to talk about plug loads. And these are kind of the least talked about section of energy end use, but they really run the gamut of equipment. So it can include things like lamps and computers and coffee pots, up to office printers and copiers, vending machines. And then on the extreme end of energy use, we have commercial cooking appliances, washers and dryers. So they really run the gamut of size and of energy use. But again, even if you just have some of these low energy use equipment, computers and monitors, they'll add up over time if you have a lot of them. And so a couple of quick things that you can do is, firstly, if you're purchasing new equipment, prioritize Energy Star certified equipment or appliances. So you hopefully have seen the Energy Star logo before, but those pieces of equipment save about 10 to 50% energy compared to more conventional counterparts. And for computers, at the very least, using low power or sleep settings is a really great way to use energy. For example, I think I have it on my screen turns off after a minute, which can get a little annoying sometimes. But if I step away from my computer, I don't know if I'm going to be talking to someone for 30 seconds or 15 minutes. And if that's the case, I'm not using my computer. I don't need the screen to be on. So this is another really simple way just to save a little bit of energy from your computer use. Another thing we'll talk about is vampire loads. So phantom or vampire loads are really what's known as, equipment and appliances, even sometimes when they're shut off or in these low power modes, they're still going to use energy. And that's due to the remote ready states for easier turn on, connection to remote servers, things like power displays, lights, clocks, and timekeeping. All that requires a little bit of energy. But again, if there's no one in the building and no chance of that equipment being used for hours or days, you don't need that energy to be used. So of course you can use things like a manual power strip, but you can also get smart power strips that just help automate this process a little bit more and save you or someone else having to walk through and unplug things or turn off power strips at the end of the day. Again, they do vary in capabilities, but the general principle is there's like a control outlet. So for example, you would plug your computer into the control outlet, and then the kind of child outlets you'd plug in your monitor, maybe a desk light, maybe a printer, so that whenever you turn off your computer, it will shut off power to the other associated appliances as well. Again, just saving you a little bit of remembering to do this at the end of every day. But regardless, a lot of what plug load management comes down to is occupant engagement, whether it's employees or tenants or colleagues, making sure that they, have a habit of doing some of these things, of looking for this. Communication here is really key. And, we'd recommend doing just a simple walkthrough of your building or your space at the end of the day, especially before weekends and holidays where, people are going to be out of the building for a while. Just walking through quickly, unplugging a few things, only takes a couple of minutes and can save you a little bit of energy. So the last energy section I will touch on is lighting. So this is typically the low-hanging fruit, relatively easy to change, offers a good return on investment. And when we think about lights, of course, most commonly we're going to think about LEDs. They are kind of the gold standard for lighting. They're getting more and more inexpensive by the day. They offer a really good lifespan compared to older types of light bulbs, and they use a lot less energy. So if you haven't switched to LEDs, we would recommend that strongly. But another thing that we would recommend is implementing lighting controls. So of course, we're all familiar with manual light switches, nothing wrong with them, but they are manual. If you forget to turn it off, the lights stay on for however long they stay on until you turn it off or, until the light burns out. So we'd recommend moving to some sort of motion sensor-based lighting control. So these come in a variety of forms. Most commonly, they'll be vacancy and occupancy sensors. So these are motion detectors that will typically turn lights off automatically. Vacancy sensors typically require a manual turn on. So when you enter a room, you do have to turn the switch, which is much easier to remember than turning it off at the end. Occupancy sensors will automatically turn on when they sense movement. You can also get lighting timers. So sometimes these are manual turn on and then they'll turn off after a set amount of time. Other times they will be like parking lot lights where they'll turn on at a certain time of day and then turn off at a certain time of day. Both of those are options. You can also get multi-level lighting. So this is great for hallways and stairwells. They work very similarly to occupancy sensors, but instead of completely turning off the lights, they will just scale them down to a lower lighting level. So you still get some safety, some security, while still saving some energy. And then there are also daylighting sensors. So if you have a space with a lot of windows, a lot of access to natural light, these sensors will scale back your artificial lighting, depending on how much natural light the space is receiving. So on a sunny day, when there's a lot of natural light, the space is naturally well lit, they'll scale back the artificial lighting load, whereas on a cloudy day where there's very little natural light, they will scale that up so that there's still plenty of light within the space. And with that, I'm going to transition into indoor air quality here for a few minutes. Indoor air quality, or IAQ, is really important for a lot of reasons that I'm going to dive into briefly here. So we care about IAQ because on average, Americans spend about 90% of their time indoors, whether that's at home, whether that's at work, whether that's at recreational activities. So whatever we're exposed to in our indoor environments, we'll be exposed to a lot. And the common IAQ pollutants that, I'll mention briefly, they can have a variety of effects, both in the short and long term. So some of the immediate effects are going to be things like respiratory irritation, dizziness, headaches, fatigue, decreased cognitive performance, and the worsening of existing conditions like asthma. On the long term, some of these pollutants and chemicals can cause respiratory and heart diseases and cancer. So not something to be taken lightly, and definitely trying to get some more awareness about where these pollutants come from and how can we mitigate some of these. So we really can break down the sources of pollutants to about four main categories. The first is going to be combustion appliances. So this is going to include HVAC equipment, gas-powered HVAC equipment like furnaces, boilers, fireplaces, and then gas cooking equipment. So all those are going to release carbon monoxide, carbon dioxide, nitrous oxides, and particulate matter. And now the hope and the intention is that most of those should be ventilated out into the outside environment, but sometimes things fail, sometimes things aren't designed correctly, and so those pollutants can leak and contaminate the rest of your building space. So something to watch out for there. The second category is building materials and furnishings. So these emit a group of chemicals called VOCs, or volatile organic compounds. Again, that covers a long list of chemicals, most of which are dangerous to human health. And this category includes finishes, so things like paints and varnishes, furnishings like carpets, flooring, and furniture, and then materials such as compressed wood products, glues, and adhesives. Of course, with building materials, we're also concerned about asbestos and lead, although this is commonly seen in older materials. We don't use those as much anymore, hopefully not at all. Similarly, cleaning and maintenance products can also emit VOCs, and if they are, a spray bottle or like an aerosol can, they can also emit particulate matter as well. And then the last category is outdoor air pollution. So, of course, all of the ventilation and air that we bring into our building, whether it's intentionally through our HVAC system or unintentionally through these air leaks and gaps in your building that I talked about, that's going to bring in stuff into your building. So things like ozone, things like radon. Radon is mainly a concern in underground or basement spaces, particulate matter. Things from a variety of sources: vehicle exhaust, wildfire smoke, industrial activity. All of those are going to emit pollutants in the outdoor environment that we can bring into our building. So how do we go about improving IAQ? The first thing that we would suggest is monitoring. So hopefully you've heard the phrase, you can't manage what you don't measure. That definitely applies to energy use and water use, but that also applies to indoor air quality. So there's a lot of things you can monitor for, but here's some common ones. So gases like carbon monoxide, which you should have alarms for because carbon monoxide is incredibly deadly in the short term. CO2, which can cause a lot of cognitive effects. This is a great indicator for how good your ventilation system is. VOCs, or volatile organic compounds, again, that covers a lot of different chemicals. There are some that are much more common, and there are kind of some subgroups under VOCs, but monitoring for that is really important. Radon, again, especially if you have an underground or basement space, and then particulate matter. So particulate matter refers to very tiny particles that are kind of suspended in our air. They're typically on the scale of microns, so like they're much smaller than a human hair. So we can't see them, but the smaller they are, the deeper they can get into our lungs, and they can cause a lot of really nasty health problems. So definitely important to monitor those, and monitoring provides a couple of benefits. So firstly, you can identify ventilation issues. Maybe there are certain areas where you're seeing a lot of CO2 or you're seeing a large concentration of VOCs. So you can then kind of use that to, get some ideas of where are we seeing these problems, what's the cause, what are some solutions that we can implement. So not only identifying the issues, but helping to inform the maintenance decisions. And then also employees or building occupants may have noticed something that they can't quite put their finger on, and IAQ monitors can sometimes validate or help track down what exactly they're experiencing. Of course, with IAQ and pollution, the easiest thing to do is to prevent them from ever entering your space to begin with. So this can really take two forms: on the policy side and on the design side. So on the policy side, this can include things like banning vehicle idling if there are drop-off or pickup zones around your building, or loading docks. Again, just trying to reduce the outdoor pollution nearby to your building. But additionally, your cleaning programs, pest management, those can often use a lot of heavy chemicals. So there are different options and different standards out there for green cleaning, for integrated pest management, that still provide you the necessary services, but in a more sustainable and healthier manner. On the design side, there are a couple things. So having a dirt track and entryway system. So most commonly, this is going to be a mat or ingrained grill, but really just trying to capture the dirt and particles that are on people's shoes before they enter the building and walk around and spread those, pollutants throughout the building. Similarly, air curtains and vestibules, which we mentioned as an energy efficiency improvement. This also works for indoor air quality as well. Again, just helping to prevent some of those outdoor pollutants from getting into our indoor spaces. And then source separation. So within your building, there's going to be spaces that just naturally are going to have more pollutants. So these can be things like copy rooms, janitorial or custodial closets, kitchens, and restrooms. So making sure that they are physically separate from other occupied spaces. This could be a physical barrier, could be pressure, and also having a dedicated ventilation system again will help contain those pollutants and not spread them into the rest of your building. Another thing we'll talk about is material choice. So material choice matters. I mentioned a list of, some materials earlier that have a lot of VOCs, a lot of dangerous chemicals in them. So whenever possible, look for low or no VOC products and finishes. Sometimes these are labeled, but a good resource, a couple of good resources to use that I'll mention is the International Future Living Institute, or ILFI. Their Living Building Challenge Red List is a list of dangerous chemicals and materials that you should avoid when you're purchasing products. You can rely on third-party certifications and information to help you choose materials. So there are things like the Declare label, which is also administered by ILFI, and then health product declarations that essentially provide a list of ingredients of materials and components that go into making a building material or a product. So you can see what's involved in it, what's in it, and then any associated health effects or dangers of using that material. And the last thing I'll talk about briefly is ventilation and filtration. So, of course, we're bringing in air into our building. We do need air exchanges, whether that's through your HVAC system, whether that's just through the leakiness of your building envelope. Making sure that your ventilation system is up to par. So we and a lot of other green building standards would recommend MERV 13 filters. So MERV is the minimum efficiency reporting value to denote how good an air filter is at capturing certain particles. So it's graded on a scale of 1 to 16. The higher numbers are better performance. So MERV 13 is kind of a good standard between practicality of, can our system still run efficiently and push air through this while also capturing a lot of those particles that we don't want. Again, regular maintenance of your HVAC system can help with making sure that, it's pulling out all those pollutants, that it's getting air into your space as needed. And then also, monitoring outdoor air quality. So we recognize that pollution levels vary throughout the year. They vary throughout the day, from traffic, from industrial activity, weather conditions, things like wildfires, which we experienced in the past couple of years during the summer. Those are going to, increase outdoor pollution levels. So adjusting your operations, maybe making sure that people aren't opening windows, that you're, taking a closer look at your ventilation and filtration system during those events. So the last thing I will leave you with before we have a little bit of time for Q&A is that we have recently unveiled our 2026 version of our indoor air quality survey. So this is going to look at some of the things that we just discussed, some additional things as well. And it's really designed to be used as a tool for you, the building owner, or occupant, to identify some of these areas, to broach the conversation around IAQ, and to identify best practices that you can implement within your building. So the link is here. There's a QR code as well. We can definitely share this after as well. And with that, I'm done with the content that I have. So any remaining time, if you have any questions, I'm happy to answer them or to follow up with more information.
Well, thank you, Tobias. That was a really great presentation, lots of great information. As you just suggested, we'd like to open the floor for questions now from the audience, and Andrew will moderate the discussion. You can either put your questions in the chat or raise your hand and to unmute. Andrew.
Thanks, Richard, and thanks, Tobias. That was a really wonderful presentation. Yeah, as Richard said, you can feel free to unmute yourself and ask questions or place it in the chat. And I will get us started as people are formulating questions. So, Tobias, I have a question from as a member of our Phipps Screen Team committee. So I am part of the subcommittee for energy reduction and waste reduction. And I was really struck by some of the things you were saying about communicating the importance of these initiatives to staff. And my question is, if the nonprofits on here, the organizations part of the network don't have a green team or don't have a sustainability manager or somebody to champion this, do you have strategies that you recommend for kind of impactful communication to get everybody on the same page?
Yeah, I mean, we recognize that not everyone is going to have a green team. I mean, not everyone has the staff capacity to have someone, solely devoted to this. There are a lot of organizations that we work with, large organizations that it's, a group of volunteers that come to talk about this. So, yeah, I mean, organizations, it varies widely. We'd recommend that there are some things that everyone can do. I mean, definitely turning off lights, unplugging your equipment, making sure to report anything that you see, because facilities, often can't be everywhere at once. So whether it's a running toilet or, a broken light bulb or, something that doesn't work or, something that's maybe light switch that doesn't turn off. That's definitely something I've heard from some folks. Just being the extra eyes and ears of whoever is maintaining your building, I think can go a really long way.
That's great. Thank you, Tobias. We had a question come in from Juliet. So the question is, I'm wondering if there are local companies that you work with and can recommend for home insulation, specifically someone who comes in and reviews how well the home is insulated and then makes recommendations on next steps.
I don't know off the top of my head. We typically don't do a lot of work in the residential environment, but Ashley, if I can put you on the spot, I know you got some insulation work done at your house a year or two ago.
I was just about to put in the chat, like putting on my personal homeowner hat. And we at GBA do not have a formal relationship with this organization or contractor right now, but I worked with InsulWise. So it's INSULWISE. And so this is not a paid advertisement. But I did have a comprehensive insulation upgrade to my home. It was actually almost exactly a year ago today. And we did work with other things, Adam. We did get quotes from a couple of other local contractors. And what I will say about InsulWise's approach was that their proposal was clearly built on a building science background. And so all of the practices and, the building science realities that Tobias presented on in this presentation, they were really thorough. And they also did what is known as a blower door test. I think Tobias, you might have mentioned a blower door test early on, but essentially it's pretty cool. It's it's a real time, and you can see it in action way for them to assess where air leaks are occurring. And the end result has been a massive improvement in efficiency in my house. I think it's like over 80%. And, of course, I feel that in real time with my heating. It was like almost impossible to heat and cool my home adequately. So Anyway, again, not a paid advertisement, but I did have our staff here, Tobias and one of our other team members who's not on the call today, look at it and say, this is a very like well-crafted project.
That's great, Ashley. Thank you for the personal anecdote and for making sure that we know it's not a paid advertisement. And I guess I have a piggyback question to that. So on the same vein, are there companies that you recommend or work with on the building level, or more on the organizational level that you would recommend?
Yeah, the one that I know off the top of my head is called Building Performance Architecture. So they do, again, a lot of similar things. They look a lot at the building envelope. They do thermal imaging, thermal scans. I think they do blower door tests as well. So again, look, I think largely for commercial buildings, but they've worked on a lot of projects with looking at building envelopes, making sure that it's high performing. There are others that do that. Building Performance Architecture is the one that comes to mind. But there are definitely others. I think branch pattern might do that as well.
Could I ask as a piggyback, Tobias, if if there would be any relevancy to the not energy as a service, the program that's being piloted through Duquesne Light Company for smaller structures that wouldn't maybe, fall under like a large commercial project. Do you think that there's any relevancy to that for this group, or is that something that you would recommend following up with after?
Yeah, I mean, I don't know off the top of my head. I'm not super familiar with that program, so I can't say who exactly it's for at this point. I know it's very new. They're like just announcing it, so yeah, haven't had a chance to really dig into that yet.
That's great. And Adam put a few links to the consultants in the chat, which we'll also post on the website. Does anybody else have other questions before we close it out for remarks? All right, great. Well, I have a few quick wrap ups before I send it over to Richard. One, so the Climate Toolkit Pittsburgh, we're about to launch a new communication listserv. So this is like a simple communication forum which you can use to ask questions of the network, to share your own resources, or to invite folks to participate in any upcoming climate events or opportunities. We're also going to be building out our resource library on climatetoolkit.org/Pittsburgh, starting with resources from today's webinar and also resources from the Allegheny County Climate Action Plan. If you have additional resources to share, please send my way. And then finally, we're going to continue to spotlight the nonprofits in this network. If you would like to share an initiative or program for our next meeting, please get in touch with me and we'll set something up for the next stakeholder meeting. So that's all I have. Thank you, Tobias. And Richard, if you'd like to close it out with some remarks, that would be wonderful.
Thanks, Andrew. And again, thank you, Tobias and the Green Building Alliance. A recording will be made available for everyone to watch and share with your colleagues in the coming weeks. And until we meet again, please consider recommending to your fellow institutions to join the Climate Toolkit Pittsburgh. Membership's free, signing on is easy, and as more institutions join us, the knowledge and connections we'll be able to share with one another will continue to grow. So thank you to everyone who tuned in today, and we look forward to connecting with you all again soon.